this year, and that popped up, and it wasn't actually it doesn't imply I wouldn't have wanted to do it, but it wasn't my initiative. So my team found it. So I think it's when you look at the different initiatives out there, it's coming and popping up as one of the major ones, and I think that's what happened as well.
Are there a lot of other like data related or AI related events in Finland as well, or what's the biggest one? I know what the biggest one is, I guess, but which one are the biggest ones in Finland otherwise when it comes to data and AI?
Yeah, I think well, there's a number of different smaller events, and then there are the large ones, and quite a lot happens around Slush, and there's a smaller event called Shift and so forth. But most of the like purely AI focused are fairly small.
But Slush is huge, right? How many people are attending that event normally?
That's a good question.
30K
it was a lot more. Now it was a little bit smaller when they were able to organize it last year. But it was great to get together again with that community. I think it's an amazing community, a lot of energy in that.
Yeah, I've always been impressed by Finland, and I've been in Helsinki a number of times in some number of events, and it's impressive. But still, you heard about Data Innovation Summit in some way, or your team did at least, and you came here. What was your impressions then of actually coming here and joining the Data Innovation Summit for the first time? Then I guess.
Yeah, I think it was clearly a positive surprise. I managed to clear my calendar and spend 2 days there, and we had an event with partners and clients the evening before, and so forth. So I think very active 2.5 days. I was mostly surprised by the sort of level of technology competence and expertise in the event. So obviously, for many, it's a marketing and sales event, but nevertheless, you really had a lot of technology competence, both in the talks and also in the audience. So, for me as a technology guy, that was exciting and interesting.
Yeah, and you had this kind of pre-summit event thing as well. I think that was a really nice touch as well. That, right?
Yeah, no, and that's what we've been doing now, as much as you've been able to do during the pandemic. So getting together in different cities with our clients and partners, and basically then running through the state of AI. So we are running a quarterly AI review, and then also sort of covering that with our closest partners.
And you as a more you of course are an academic person as well, and you can think about these kind of more industrial kind of conferences or summits in different ways. Either you hate them or you love them, or I think a lot of people have the wrong view of what the differences are between industrial conferences and more academic conferences. Do you have any preference between the two, or what's your opinion about these type of more industrial type of conferences?
Yeah, I mean, I think they can be very, very different. So if you look at really these conventional academic conferences, then they're certainly different.
Do you have any favorite academic conference or?
Yeah. I mean, I do have. We had ICML, for instance, here in Stockholm just a few years back, and
awesome.
And Nordics is good, and many others as well. But I think what I was actually going to say was that there's been a major shift in that, because we have more and more industry partners joining these academic events. So events like ICML and Nordics have actually become sort of fairly industrial, and I think they are a good mix of it.
Good point.
Yeah.
So you think there will be some kind of convergence between the two in the future, or what do you think?
I think it's partly for the benefit, but then partly I do think that it's good that there's also sort of purely academic conferences for that purpose. But I don't think I don't think there's gonna be a total convergence of all academic activities even though ML and AI is a topic that also is relevant in industry.
I think the two have different purposes, and I'm speaking a bit subjectively now because, of course, I'm helping with the organization of that specific conference and working with Goran here to do that. But I think that they have different purposes and they're both useful in some way. And if you want to truly just understand, the latest perhaps science from a more like technology point of view, that could be one thing. But it's also about trying to understand what is really the market needs right now. What are companies really thinking about? What is the true value that you can bring as a company if you want to get started with data and AI. And then I think actually these kind of industrial conferences have a better measure on that. Would you agree with that? Or?
Yeah, of course, and I entirely agree with that. So if you look at what topics are being covered in ICML and NeurIPS, and then you, as sort of a first-time applier, start to apply those technologies, it's not a good idea, no.
Yeah. I guess it's a big divide between the state of the art of the more academic research versus what the industrial type of useful research is, or how would you phrase it? Is it?
Yeah, I mean, now if you look at the number of papers by the big tech companies in conferences like NeurIPS and ICML. They're taking a larger and larger share of the sort of also the sort of publishing role there, and I think they are a major part of it. But then if you look at like more immature companies in terms of AI and ML technology, it doesn't necessarily give them much. So I think those that are doing a lot of advanced efforts in R&D. Related to the field benefit, but for those like starting out and applying, I don't think it really helps that much.
I added that as a topic because I think it's interesting to just think a bit more about what will the future be of this, especially as we see the big tech giants. That they are really taking a even greater and greater part of also academic conferences and of course of industrial ones as well, and they are really growing in a scale that is awesome in some way, but also a bit scary in another way potentially. But let's add that as a second topic and get more deeper into that, because I think it's fun that you just as me have both an academic background but also an industrial background, and trying to see the benefits from both sides. I think is really interesting and useful to consider, right?
Yeah, no, indeed, and obviously. There's gonna happen a shift when a lot of the activities that now are seen as academic activities are gonna be sort of conventional R&D in companies rather than academic activities, and that's if you look at the field of AI and ML disciplines in academia, then they have also changed quite a lot in the past, say 10-15 years.
And I've been a strong proponent for more industrial type of research, actually having research being conducted in industry and in companies as well, in combination or as a complement to universities. But that is not always easy to achieve. But I think actually you have managed to do that in a really nice way in Silo. But let's not go there right now. But I would love to hear your thoughts about how to really make industrial research work in a good way, and how you can also have companies conducting research in a balance with engineering, if we call it that, in a nice way. It's a tough, choice or balance to consider, right?
Yeah, it is. I guess like in many technology waves, that shift from like being a research activity or academic activity to actually being something that you apply, like is in everyday use and you apply in practice. I guess in many technology waves that has happened slower. Now it happened in a few years, right. And I think that has implied that a lot of the sort of activities are somewhere in the sort of intersection of academia and industry, and then you will also benefit more from doing academic research in industry and vice versa.
Yeah, such an interesting topic. But with that, let's welcome you here, Peter Sarlin. It's a true pleasure to have you here. I would consider you one of the top AI people in the Nordics, so that's why it's extra interesting to have you here. And And I think, you don't only have a deep understanding of the technology behind AI, but also from the more economics side of things, which I think is rather rare, and how it influences society in different ways. Usually you're a tech nerd like me, but to have both the understanding of tech and economics of sides is, I think, very unique in some way. But also, I mean, you have done so many other things. I mean, you have, of course, you're a co-founder of Silo AAB, and Silo. Was it really the right name? Is it Silo AI, or is it Silo AB, or what do you call it?
Silo AI.
AI, of course. And it's the largest private AI lab, I guess, in the Nordics as well. But you also have done a large number of other companies that you have founded in the past. And it's a bit surprising to me how you've been able to do so many things, still being as young as you are. And of course, having still a PhD in, it was specializing in ML, right, in machine learning, but still with a more focus on how to achieve, I guess, financial stability in some way. Right?
Yeah.
I'd love to hear more about that, because it's another hobby interest of mine in really how to make that happen. But also, I think one of the main thing I really like is that you have actually a view of how to make the best use of AI, which I very much agree with, which is that it's really about using AI together with humans. It's not really about replacing humans, but if you actually find a way to work humans and machines together, that's really the best way to achieve like a positive and beneficial impact of AI in our society, right?
Yeah.
Or am I putting words in your mouth, or would you agree with that?
No, I think that's very well aligned with what I think, and that's also very, very well aligned with the vision of Silo AI.
Yeah, same way. Awesome. But with that, Peter, how would you describe yourself? Who is Peter Sarlin?
Yeah, that's an interesting question. Not sure how far back you want to go, but I think you did you got certain parts at least correctly in the introduction, and not sure how well I've succeeded in different parts, but I've done many different things. And been probably a little bit difficult to sort of put in that little box and sort of categorize as either, say, industrial or academic or.
I mean, you're also a professor in what was the title of the professorship you have?
Now I've moved to a professor of practice position, which is in like applications of machine learning. So indeed, I mean, there's been both industry and academia, but also in academia there's been a lot of different topics that I've been covering. So I actually, in line with what you just said, I've sort of had an interest in the societal aspects as well. I actually come from having a bachelor's and master's in economics,
right, and
did a lot of maths. A lot of economics is maths. I've been always interested in sort of the sort of behavioral aspects of say in general the world, and then eventually didn't believe in the way that in macroeconomics we were modeling the world. That implies that you're sort of using mathematical, you're in Hilbert space using mathematical models modeling the individual human behavior.
Yeah.
That was like just before and at the start of the financial crisis. And
so that was in the beginning of 2000 then, or?
The global financial crisis, so that was in 2007, 8, 9.
Yeah, okay, that one.
That one.
I was thinking about the IT bubble as well, but okay, that was another big economic crisis later, right? Okay, so cool. It started from more of an economics kind of interest, and then it evolved somehow. How did you get interested in machine learning then?
Yeah, I already started to. I've been sort of playing with computers from a young age, and then sort of. I actually started my PhD here in Stockholm.
Oh, you did?
So I did my first year here. Brilliant maths teachers.
Which university was that?
Stockholm University, but the PhD program is joint with Stockholm School of Economics. And but eventually then decided that I believe more in machine learning when it comes to financial stability surveillance, and that was the topic I was already looking at the time, and then ended up spending. I then moved to machine learning and did a PhD in applied machine learning. Ended up spending half of my time in academia during the PhD and half of my time at central banks, mainly at the European Central Bank.
Oh, really? Oh, that's really interesting. So what does it mean? Financial stability or stability surveillance? Can you just elaborate a bit more? What was that?
That was the thing that central banks were not focusing on before the global financial crisis. So mainly having sort of being tasked with monetary policy and safeguarding price stability, and being fairly light on then tools to actually measure and monitor financial stability. I guess that partly contributed also to the fact that we put in place some of the first machine learning based solutions for that topic. So I can't say that we did anything that groundbreaking, but you know, we built some of the first solutions then, and I think that was the first time I really saw the impact of machine learning. You know, you can call it statistics even, depending on how you actually define your neural network, but an AI then as well.
Okay, so you know, I'm very ignorant when it comes to the economics of how stock markets, etc., work. But can you perhaps elaborate a bit more? What was the cause, or what caused the big crisis that we had in 2007 and 2008, so forth, at that time?
That's a deep question. I think what I've been intrigued by has been more focusing on what we can actually measure in terms of better anticipating, and the cause is usually a shock, and that shock can be anything. Yeah. And I believe that's to a large extent unpredictable. But what we can measure is the imbalances that build up before crisis. Right. So when you actually become vulnerable to shocks, and that's the sort of part of it that we've built. Then back in the time we've built models to measure the vulnerability of the system as a whole.
So and how can that be? What caused the stock market or whatever market you're thinking about to be vulnerable? Can you just elaborate? What kind of shock are you speaking about?
Well, the shocks can be of different. I mean, you mentioned the dot-com bubble, and 9/11 was a shock, yes. And the housing market in the U.S. Right. Had a shock, and so forth. And then, the vulnerabilities that you can measure, they relate to various things like, say, the credit levels and the growth of the credit levels, and the asset prices and the growth of the asset prices, and the connectedness of the system of banks or other financial intermediaries, and so forth. So, there's a bunch of different things.
And what, if you were to try to just summarize, rather, in simple terms, what your PhD was trying to do, was it trying to predict the vulnerability in some way, or the potential outcome of a future crisis, or?
So what we did, and what I did in my thesis was to build tools to measure the vulnerability of the system, and. What you can say is that you can't really predict whether there's a shock that's going to happen or not. But what we built was models that are actually still in use. So I would say that every single central bank has something of the research that we did back in the time. I mean, there was nothing before that on the topic, or single small contributions, and nothing in really in use. And then,
so what kind of input can you use for that? I mean, if you use some kind of machine learning approach, you need some data that you can feed into the system and try to train some system on. Can you just describe briefly what kind of data you can use to try to understand the vulnerability?
Yeah, so I think the summary of obviously we had several contributions and several tools are then being used in different ways to steer policy, but and then it's a discretionary policy still, so it's sort of not a machine that is taking decisions on its own behalf, but as an example, I think one of the concrete things and advances was the measurement of vulnerability at the bank level, and then basically connecting that through or connecting each of the banks to each other by viewing it as a network, and then measuring the vulnerability of the banks as a function of all of the other banks, and then by that you can measure the vulnerability of the system as a whole as well.
So if a certain bank becomes extra vulnerable, then the connected banks can also become that, and it becomes kind of network effect in some way.
Yeah.
Okay. Interesting. And how do you understand if a bank is becoming vulnerable, then a single bank, so to speak?
By basically analyzing the individual indicators that are measuring sort of in financial or other terms the state of that specific bank. And
sounds like you don't want to disclose the secrets of the algorithm here.
No, I mean it's all published and out there. So, but I think really what from a machine learning perspective, what we did was that we developed, and there's there's contributions in terms of tools that are in practical use. But what we really did was to then further develop machine learning algorithms to directly sort of support the task that you had in practice. And I think that's been sort of a driving force in many things that I've done ever since, that you actually sort of, first identify the domain problem that you have. And then after that, you take existing methods and approaches, and then you tweak and twist until they are actually sort of serving that task at hand. So a lot of the publications are in finance and economics journals, and the other half of the publications are in machine learning journals.
And you had a huge number of publications, if I'm not mistaken, as well. It's like 40 publications or something. Was that just during the PhD work, or was it before that as well? Or
Yeah. So I've been a little bit on and off with things. So when I turn my attention to something, then I do it 110%.
You must
so
be.
I did. Yeah. So I mean, I without being actually that sort of academically oriented, got started with my bachelor's and master's studies. Then fairly rapidly in 23, a bit less than 2 years, did. 5 years of studies, and then jumped into a PhD. Indeed, we published quite a lot with many colleagues, many co-authors. I think around 60 publications or so in sort of 4 years, and then graduated in 2013, and in 2014 started in a professorship. So that was sort of the short period of like fully focusing on I think many interesting applied topics, but also many interesting contributions to methods in the field.
I mean, given that you seem to have a knack for being really productive, both in academia and in industry later on. What's your secret in that sense? Do you have a way? Is it just to work hard, or is that do you have some secret or some tricks that you apply to just be as productive as you have been?
I don't know. I think you need to. I focused on the things that I do, and then you need a lot of grit and perseverance to push through. But I don't think there are some things that are obviously sort of. That have had a major contribution to certain areas, yes, but at the same time, I mean, I've chosen my battles and put all of my focus on that when I've been sort of, when I've had a target to, for instance, get to the best journals, then that's what I focused on, and then you need to leave out several other things. So I had the chance in my sort of academic career to push quite heavily on research activities rather than teaching activities or other bureaucracy, which I know many are doing in academia.
Yes, certainly the case. Okay, cool. So one, you were able to focus and do that on what you really wanted and get rid of some bureaucracy that otherwise is necessary. But still, how does a normal work day look for you in that case? If we take the academic times, for example, do you work long hours or?
Well, certainly. I've always done that, and it's in most cases it's not really work. It's what I sort of really, what I'm really sort of eager to do, and in many cases combining a hobby and work, and it does require a lot of effort. But then at the same time, I've in many cases, I guess, been able to also sort of connect the dots between many things and sort of find synergies as well. So like as an example, in academia, when we went out with sort of say a new machine learning algorithm, then eventually we were pushing already on 5 different work streams on how to apply that in different industries and so forth. And the same thing with developing algorithms, when you do one new further development, then you already have 5 new ideas that you are pushing forward with. So I think sort of connecting the dots between many of the things that you do allows you to actually find synergy in that.
You make it sound very simple. I think it's not as simple as you make it sound, but I think I understand what you mean. So trying to really find the best effect in some way of whatever kind of, if you do some work, trying to really make that effect of that work also become as high as possible, or how should you phrase it? Is that?
Yeah, I guess so. But I mean, I wouldn't downplay sort of the importance of grit and perseverance. I mean, in many cases, not only the hours, it's
blood, sweat, and tears,
yes.
Right?
I mean, if you decide to go through that wall, then you go through that wall.
So that is, if you were to give some tips for someone that wants to be as successful as possible, is it perseverance or blood, sweat and tears, or is there some tips you can give in just making sure that you can be as focused as it seems you have been able to be?
No, I mean, what grit and perseverance eventually will mean is then and imply is that you're going to fail, and you're going to fail many times. And, as long as you learn and find new ways to push forward, then, you are going to go forward. And I think eventually, that's, and then you need to, be willing to put that hard work in when it's required and so forth. And, yeah.
Ability to fail. I think if you don't fail, you don't learn. I've heard some people say, like Elon Musk, etc. So I think it's a good statement, I think. Okay, cool. But you did your PhD, and what happened after that?
I did my PhD in 2013. Had already then been sort of half in industry and half in academia. Moved to Frankfurt, spent a few years with Goethe University and also with the European Central Bank. At that time already started out doing more and more sort of industrial engagements related to sort of applying AI in practice, applying machine learning. AI was a swear word or at that point still. So
that was before deep learning really had broken through in any way, right?
I have to admit that I still have a little bit of a difficulty to talk about AI, but so yeah, and enjoyed really a lot to see sort of the impact of the work that we did with central banks. So seeing actual use of, in many cases, not that advanced machine learning even, but seeing that used in practice. And then got my professorship in 2014.
Right. And at what university was that?
That was at Hanken School of Economics. So basically combining the focus on machine learning and finance.
Was that your full-time occupation at that time? or did you have other projects at the same time as well?
Yeah, so I've never been in a full-time professorship, so I've always wanted to assure that I also have time to do other things, and I think that's, from my perspective, been sort of an issue with academic positions, is that most of the time you end up doing other things than your own research or your group's research. But for me, that has been a good path forward.
Mm-hmm. Cool. And so you part-time at least worked with the professorship. Did you have PhD students at that time as well, or what?
Yeah. I've had a few. I still have one. So many of these things are, as you know, I ended my professorship in so basically when we set up Silo in 2017, resigned and then shifted to a professor of practice position.
Right. What does that mean, professor in practice?
Professor of practice, I think that's become more and more popular, basically, from various angles, sort of getting in the industry or practice view on research, and I mean, obviously the path that I had to that wasn't really the normal one, so mostly you move to a professor of practice position after a long career.
Yeah.
But I found it fairly good, in the sense that we still had a research group in place, and we still had ongoing research projects and PhD students and so forth, and could still support with that, and then obviously sort of also from the angle of what is happening in industry, help the university forward as well.
How much, what percentage of your time are you still putting into the professorship of practice, so to speak, today?
Yeah, no, it's always been on top of all of the other percentages. So I think that's something you need to do for the love of the game, and but I mean, it in practice it's been something that is in a tiny role, so 10% or so.
Yeah. Okay, so I know you had a lot of other companies that you worked with, but I'd like to, for sake of time, to move quickly into Silo AI, and perhaps you can just speak about how did that come about? What was your initial thinking when getting the initial idea of starting the company of Silo AI?
Yeah, we were and we are a team of 6 co-founders, and at the time I was moving back with the family from Germany to Finland, already involved in a number of industrial activities, seeing the impact of machine learning, and also the sort of growth of the use of machine learning in industry. I personally saw that if we do this as a commercial activity, then we are most likely going to have a bigger impact in the world.
And do that. What do you mean with what did you want to do as a commercial?
Yeah. So that was my perspective, and then that basically it was a joint view by the co-founders that the market needs a technology player that can help others succeed during this AI wave or technology wave. And especially by sort of connecting top-notch world-class academic talent and industrial problems. So that was the sort of angle we took to it. And in addition to myself, we had another professor, Kai Mikael Björk, involved. Right. My research group joined to a large extent. We had Tero Ojanperä joined, former Nokia executive CTO. Right. We had Juha Hulkko join as one of the co-founders. He's one of the founders of Electrobit that was sold to Continental a few years back, long-term entrepreneur, and so forth. So we had a strong team with both technology and academic competence and also experience from industry and business.
Right.
And I think that functioned as a very, very good basis for us to get fairly rapidly started.
How would you define the vision and the mission of Silo AI?
Yeah, so that's a good question, and there's not going to be a short answer. The mission is to assure that Europe has a flagship AI company, and the vision is AI for people. So basically, building human-centric AI. And let me start off from the mission. So the mission, and that was really the sort of impact we were looking for from the very beginning, and implied that when we got started and we were just a few people, we already had the sort of ambitious goal of building a European flagship AI company with the intent to assure that we are keeping leading AI talent in the region.
Right.
We had a talent drain already then. We still have a talent drain in Europe, in Nordics, in Sweden, in Finland.
And talent drain to what, would say, to the tech giants, or what? How do you describe the talent drain?
Yeah, I think the easy answer is tech giants, but in many cases it's more complicated than that. But yes, I mean. And then also to assure that companies in the region have a partner that can help them succeed on their AI journey. So we, from the very beginning, we built a trusted AI partner, a service company that helps others succeed on their journey. And then when it comes to vision, that has been, when I say AI for people, it's actually very technology driven, and it relates to what you said in the beginning. So we believe in sort of the combination of AI and or artificial and human intelligence, AI and people, and that comes from the fact that at the very core of it, we will have humans. The state of the technology and the technology we have is not going to sort of, create AGI or super intelligence, but narrow intelligence. And that technology is here to help us humans perform better. And we are gonna have AI at the very center in terms of, say, creating data, in terms of creating algorithms, in terms of, in most cases, using those AI solutions. And that's been sort of the technology view we've had on it always, that if we assure that humans are at the very center, we are actually creating more value than running after all of these sort of hyped topics and technology areas.
And can you just elaborate a bit more? I can give a bit of my view as well on this and see if you agree or not with that kind of statement. And I would argue that AI is good at some things and people are good at other things. So one thing that AI can do is going through a huge amount of data in an efficient way, but does so rather superficially. And people are actually not really good at going through large amount of data, but it can go through a small amount of data in a much more deep way, in a way that they can put things in a context with the background knowledge that they have and the reasoning capabilities that they have, to an extent that AI is not it's not possible with the AI of today. So therefore, if you remove the tasks that people do today, which is really mundane and repetitive, which usually involves going through a large amount of data in some way, and instead use AI for that and let people do what they really are good at, which is more trying to go through a small amount of data, but do that in a much more reasoning way, then that is the best way to combine AI and humans. Would you agree with that?
Yeah. Yeah, I think that's a good way of looking at it. I mean, my perspective, which is not sort of contradictory at all, but is that the technology we have is machine learning that builds A to B mappings.
Mm-hmm.
That is supervised learning.
Mm-hmm.
And we can do that very well. But when we do that, that's that's by definition narrow AI.
Yeah.
And that requires you to pre-specify that mapping, A to B mapping, be it from speech to text or from documents to classes or from images to categories or some other mapping. Then eventually once you do that, you can do that at scale, which is what you said machines can do. And then you can have humans do sort of those deeper level tasks on top of that. I think that the technology we have and that is being developed and that is rapidly developing is not only supervised learning. That would be exaggerating. But all of those other technologies, or most of them, especially the ones that are applied, they are supporting in one way or another you to do better supervised learning, do better A to B mappings. And I think that's going to sort of limit us from moving to what you described that humans are good at.
Yeah. So, I mean, there are a number of people that are pioneers, I would say, in AI. And if we take someone that's, I think, is saying something similar to what you're saying, like Jan LeCun or someone like that, is saying that, it's the, I think he phrases it as the icing on the cake, and then you have a cherry on top of the cake. And I think the cherry is the supervised learning, the icing is more reinforcement learning, and the big part of the cake is more unsupervised learning. And I guess in his case, he's a very big proponent of self-supervised learning, which is more or less unsupervised because you don't require any manual annotation, at least for that. Do you agree with him? I'm not sure if you're familiar with his work, or what do you think about that type of thinking?
If you look at the views that Jan or Joshua or other other sort of fathers of deep learning have, then rightly so, they've been sort of partly, I'd say, over biased towards deep learning and its capabilities, but at the same time,
I think Hinton was actually very against deep learning in the beginning, but he switched over, I guess, to some time. But yeah, sure.
Yeah, and all of them have a little bit different. Like Jürgen Schmidhuber has his views as well. And
what do you think about Schmidhuber, by the way?
Well, I mean, he's done some major contributions. He did LSTM much before anyone called it LSTM, and so forth. But I think
it's a very controversial way of phrasing himself in different medias.
I don't respect that too much. But nevertheless, I mean, he's done some major contributions, and you can't take that away. But I mean, that's only one tiny part of all of the contributions done in the world. So. But yeah, back to the sort of, I still think that some of the topics are being, without referring to like individual, say, professors, some of the topics have been a little bit oversold and overhyped. My perspective, and that's been my perspective always, has been to be a little bit more sort of realistic in terms of what can actually be applied in practice.
Right.
But I think as a professor and as a researcher, you're sort of supposed to aim for the stars, and then that's the role of someone like Silo to then assure that these technologies are being applied to the correct things.
Yeah. Yeah, and I like what you say that, you know, we have to find a way not only to look for the long-term vision, but also to have short-term values for AI. And there are a lot of short-term values that you can gain today by making the right use for it. Another person that I actually do admire a bit is Jeremy Howard. He was a previous, I think, he was the founder of Kaggle, I think, in the beginning, and now the founder of Fast AI. And he phrased something, let's see if I can remember it correctly. I think he said a statement like, most research in deep learning today is a complete waste of time. And if I were to paraphrase him, he's trying to say that so many things is being spent when it comes to academic research in just finding, 0.1 percentage point higher accuracy in some kind of leaderboard for some kind of academic data set and task. While in reality, if you want to apply something in research, there are so many other problems that you should focus on to make it work for real in some way. And I think he means like active learning and being able to work with small amounts of data and these kind of things. Would you agree with that? That a lot of research today in academia is actually a waste of time?
I mean, yes and no. I mean, it's and he was referring to deep learning. But, depending on what angle you look from, you can say the same thing about all research, right? If you are looking at it from the perspective of a very, very applied viewpoint, it's not going to be relevant for you. And it might not be supposed to be. So, I mean, then you will end up in a discussion sort of what is the role of research in society overall. Now, I think, you can then decide to accept or not accept that 1% is going to be relevant for practice. Right. And I think that's more like a philosophical discussion to the role of research in society. But I think that's probably true. That the way that I look at, the way that I and Silo looks at the sort of technology wave that is happening is that it's not really even about algorithms. I mean, yes, they are changing, but I mean, it's not that someone came up with a new deep neural network architecture that changed the world. I think that the major thing is that now you have millions and millions of developers out there sort of hacking together libraries that can be used in practice rather than having some thousand relevant researchers doing publications or doing basically writing code for the purpose of publishing papers. Right. And then if you take even a further step up and look at from a higher abstraction level, what is actually driving this technology wave? I wouldn't say it's actually sort of AI at all. It's and this is how we are looking at it at Silo. It's what's happening to ML infrastructure. It's what's happening to data and sensors and how we basically collect data. It's what's happening to compute and where compute is moving, so closer to devices and the edge. And connectivity, so how we are basically moving and transferring data. And then obviously sort of there's continuous development on algorithms, but as many that have been in the ML field know, we are playing around in many cases with the same algorithms that have been around for 20, 30 years. A lot has happened, yes, but like the major breakthrough isn't necessarily really that. Yeah. But I don't know if you agree.
I actually do to a large extent, but let me try to, just for the sake of argument, have a discussion around this. And okay, there was a paper, I think it's in 2015 or 16 from Google, I believe. It was called The Hidden Technical Depth of Machine Learning. And they had, I think, a very infamous picture which put the ML part in a small square in the middle. Perhaps you can find this if you Google for it, Goran. hidden technical depth of machine learning in images.google.com. Yeah. And then they could see the ML part was in the middle, and they have so many different like boxes around it and components and parts of a system that is required to actually put something in practice. And so many people completely mistake, I would argue, what's necessary to truly make use of an AI system today. And it's a very small part. It's about the model itself or the architecture, as you say. You go to images, Goran. Sorry. Go up there in the images. Yeah, I think the first one here or something should. Yeah, the first one there. You can see the small black box in the middle there. That's the ML part, and then you have all the things around it. And just the serving infrastructure by itself is actually much more work to truly make. I think it's similar to what you said. The ML infrastructure, in some sense, is really what requires so much work outside of the whole modeling part to make use of things. And this is a big misconception, I think, out there if you want to make something work. So in that sense, I fortunately agree a lot with what you said. I want to find a counterpoint here to what you said. But is that basically what you are referring to? That the model is one thing. We have, for example, what Andrew Ng has been speaking about, the data-centric versus model-centric, and it's more about, if you can improve the data quality in some sense rather than the model quality. But then I would argue the whole thing here about the whole infrastructure around it is also so much more work, and it's really what's necessary to have is the developers that you spoke about that's necessary to be there to build these systems. Is that, do you think, one of the big reasons for a lot of companies failing to use AI today?
Yeah, probably. I mean, if you, however you want to call this ML infrastructure part, ML ops or something else, I mean, my take on that, and we're working with quite a lot of companies, both really large and small. No one has it in place, and no one is happy with it. No one is ready. There is no de facto standard. So, if you are an industry-leading global player in whatever, automotive or in among the big tech companies even, you are not there. Or if you are a startup, a recently founded company and building it from scratch, you are not there either. So there's it's not really even a matter of depth in many cases. I would say that there is no de facto standard.
Right.
So at the moment, my feeling about MLOps is that everyone is a little bit reinventing the wheel, and we are still looking for that industry standard to do it. And that's part of the game, right? I mean, now we are coming up with ways of working and so forth, and then in many cases you need to find your way forward, and that's gonna gradually improve, and that is an important part of it. So if you look at how machine learning was done 10-15 years ago, in most cases it was only that sort of ML code there in the middle. And then you did some kind of, you built some kind of a model, and which, output was some parameters, and then you deployed that. And then it was basically sitting there among all the other code. But then, I mean, I think a major part of how I'm looking at the world and this technology wave is like the data, compute, and connectivity part of it, and I think that's gonna significantly change. So it's really not a sort of cloud story anymore, and it is really about where you can do that compute. Again, if you go back 10-15 years, even in academia, you worked very differently.
Yeah, awesome. We could speak about this for a long time, I think. But I want to get back as well to Silo AI. And You mentioned that the mission and vision was, that we want for one to have a EU flagship of some kind of AI company, but also use AI for the people. But to be even more concrete, why should a company reach out to say low AI? Can you just say what are you trying to help them with in a concrete way?
Yeah. We're basically helping companies build AI-driven products, and there are many angles to this. One is that, and we can maybe touch upon that later on. I won't dig deeper, but really viewing the sort of the AI journey you enter as a product development journey. You need to commit to it long term, and you need to put it at the core of your product or your processes or your services. And in order to succeed, and we can help you with that. We are sort of, and we have tried to stay away from these sort of hyped AI topics and AI discussions, experiments here and there, and proof of concepts and so forth.
Just staying a bit on that topic, because something we've been speaking quite a lot about in this podcast as well is a topic called the prototype graveyard, and what we mean with that is we can see so many companies that wants to get into AI and even claiming to be using AI, and what they usually do is either to have like a thesis student trying out some kind of AI model in some way for some problem, building a small prototype or proof of concept for that, or they even may be hiring some data scientists, putting them in some team, and they are trying to experiment with different ways to use AI for some of their products that they're having. But then, okay, let me make a claim here and see if you agree or not. But I would argue that it is wrong, for one, to simply build the prototype by itself without having the engineers in place to also build the whole product in itself. If you do the two separately, you first build a small prototype and then you hand it over to someone else to do the rest of the product, it's not really going to work that well. Rather, you should have like an integrated cross-functional team doing both the ML modeling and the engineering of the whole product. Otherwise, it will be really hard to make it work. Yeah. Would you agree with that?
I would entirely agree with that, but I think what is like that's indeed the way that I think it should be approached from the perspective of like building out a team and executing. But I think most importantly, you need to be committed to go all the way to production, and you need to have that vision.
Goran, we have to give him one of our T-shirts later. We actually have been saying this so many times. It's we have a hoodie or a T-shirt, or what is it? Yeah, it's a hoodie. Yeah. So we have actually a hoodie, and we will give you one. It's called "Commit to Deploy," and if you don't do that, then you're not going to succeed.
That's good. And the thing is that it doesn't end there. You deploy, and you still need to be committed, right? So the thing is, it's ongoing long-term commitment. You don't develop a solution. It's not a project starts tomorrow and ends in a month, and then you're done. Then it's deployed. But you need to be there to further develop and refine. And there is sort of there is no start and end.
Yeah. It's no. Yeah.
Great. Now we need to print a T-shirt which basically goes under the hoodie. So commit to deploy and then and stay committed.
And stay committed. Yeah, with the text underneath or something. Yeah, love it. Okay, so if I understand it correctly, and please correct me otherwise, but of course you for one need to have the data in place. You need to have the model in place, but you certainly need to also have the application in place and deploy that. But it's really when you also have the full feedback loop in place where you use the application and continuously improve it when you make it work. Would that be an accurate summary of what you're trying to say?
Yeah. I mean, I think that feedback loop can look very different in different contexts. Mm-hmm. So I don't want to be too strict on that part of it. Mm-hmm. it needs to be part of your product development roadmap, and it's not sort of a loose, separate point solution that someone is gonna deliver and maybe even deploy, and then it's sort of gonna live a good life there on its own, and then the feedback loop might look very different in different cases. So like moving back to try to actually answer your question. So your question was like, who should reach out, or why should someone reach out to Silo? As I said, we're helping companies build AI-driven products, and we're now a team of around 250 people. Majority of our team has a PhD in AI-related technologies.
And that's really impressive. Has that been a conscious choice for you to hire so many PhDs, or what's the reason for that? We started out with a strong sort of focus on. I mean, you have to remember we're not that old. We're 4.5 years old. Yeah. But we started out in a market that was fairly immature in terms of clients, but also in terms of like expertise and the sort of the AI capabilities in industry. So from the very beginning, we've been basically identifying and turning academic talent to like data scientists that can contribute in industrial projects, and I think that's been fairly unique. And now, indeed, as you say, it's quite a big concentration of really senior AI talent that has, say, 5 to 10 years of experience of actually applying these technologies in practice. And so yeah, I mean, that if you look at pure play AI service companies in for instance, Europe, there are not many, if any, sort of larger players with this like pure play AI focus. But then, if about half of the team is that kind of talent, then the other half is engineering and software development talent to build like scalable infrastructure. Actually, like when you've built modern machine learning algorithms, how do you actually bring them to production and run them and operate them at scale in production? So those are the two sort of spearheads we have. And then we have own infrastructure that speeds up actually like bringing machine learning to production. But again, we're not approaching it from the viewpoint of like one platform to rule them all, but rather from the viewpoint of having sort of that infrastructure that you can then customize for the purpose at hand. Cool. So you're not selling a product or an infrastructure, but you do have some, what should we call it, stereotypical kind of solutions that you can reapply and customize to the customer needs, or how should you phrase it?
Yeah, so it goes under the name Silo OS. It's not an
Silo OS, like operating system, or
yeah, but it's operating software. And it's basically a modular components that we sort of reuse in like delivering. So we have an annotation platform. We have an MLOps like framework that we then customize for various needs. We have a development and deployment platform that we again make use of ourselves and then customize for client needs. But I think all of these parts, building them as a off-the-shelf offering is really, really challenging.
Right. So you need to customize them often, you would say, and
yeah, I mean, I would say always if you are actually to create significant value, and then you have to remember that we are sort of in core products and processes, so we are usually sort of really building competitive advantage and differentiating.
So that is what you get if you become a customer Silo, that you, for one, you can reuse some of the modules, components that you have there to, for one, annotate or just do development and deployment in an efficient way. Do you actually integrate that into their systems as well, or do they rather integrate with your systems, or how does that work?
Normally we fully integrate with their systems.
Mm. Yeah, I mean, that sounds great. But you do also have like a large lab or something, if I'm not mistaken. Please correct me if I'm wrong. But for one, you're doing the solution engineering, if we call it that, for the clients you do have. But do you do also more, let's call it research type of work as well?
Yeah, I mean, we are running you call it lab, innovation lab type of activities indeed. So we have a really strong like academic background, and also
120 PhDs, I would imagine so. Right?
Yeah, and obviously an interest to contribute. So we are doing innovation projects within that scope. And contributing to sort of innovative projects, but I think it's worth noting that we are we've from the very beginning been customer and client focused in our sort of way of looking at the world, and people within Silo get the chance to contribute to some of the say flagship programs or products where we are helping clients, be it then in automotive or smart devices or other initiatives. So most of our work, I'd say almost all of our work is focusing on building value to our clients and helping them succeed. And that's also the talent that we have been able to attract is not sort of purely an academic mindset, but an academic background, but then mindset to actually build value and contribute to real world products.
That sounds great. But can you mention perhaps what are the more like innovation type of challenges that you are focusing on right now or coming years? Or are there some specific challenges that you think this is not really working that well and we really need better solutions for doing something, and we need to conduct more research or innovation to fix this?
There's more problems than we have resources, so obviously we need to pick our battles correctly. And given that we're a tiny company compared to many, then there's only so much we can do. But that said, I think one major challenge that we continuously see is related to, say, data quality, but that's a huge topic. So in particular to, I would say, labeling and annotation, and getting high quality, high volume of high quality labeled data. So we have our own, and really, I mean, it's the backbone of it all, but we have our own annotation platform. And the purpose of that is that the way we look at the sort of need of an annotation platform or tooling is that it needs to be customized for that particular task at hand. So you need to customize everything from say the user interface to the machine learning algorithms in the background, and even to the specific sort of data quality checks that you're doing on the annotation tasks that you have. And I think there's a lot of I would say low hanging fruits, in a sense, contributions that are really, really important for industry at the moment, that need to happen in how you speed up labeling. Synthetic data obviously is one where you wouldn't be labeling, but then everything from semi-supervised learning to active learning and so forth, and how you actually embed it into like well-working, functional, like user-centric processes. Those are terms, also those last terms, but the terms active learning and semi-supervised learning, we've heard them for a long time. But it's quite limited when we look at how these kind of new technologies are being used actually in practice. So I think a lot of that is like in high demand and needed out there, and the tooling that is out there is either quite sort of immature or then quite specific. So if it's specific, then it's most likely not relevant for your need at hand.
Right. Yeah, interesting. And still just lingering a bit longer on the top challenges for more innovative or research, kind of questions. One, of course, is the data quality, as you've been speaking about, and it could be the labeling quality or the data itself, or synthetic data and active learning to just finding what to annotate and what not, or combining it with semi-supervised learning. But there are other trends, I would argue, in the research community as well, trying to instead change how the models work to reduce the need to do labeling and to move more into biting my tongue because I actually don't like this trend, but I'm still going to say it. But there are ways to also move more into zero-shot or few-shot learning with using large foundational models or large language models, etc., where you can then potentially start to find use without having to label that much or even anything, or just prompting models with examples and then having it understand how it should work. What do you think about that trend that we're seeing in a lot of with GPT-3 and Gopher Sight and DALL-E, or so many different things that are happening right now?
Yeah. No, I think foundational models as an example, they're already in pretty significant use. But
do you find, if we take these kind of large language models, can you see a practical use today with GPT-3 type of style, or the new one from Facebook called OPT that is similar in size and now open source as well, and people could potentially make use of it? Do you see a big practical use for that today? Or would you prefer to use more traditional models and labeling techniques to train them on their own data that they may have?
I would say that in most cases it's not the best tool.
Yeah.
But or it's not the needed tool.
Right.
But I mean, like foundational model as an example, they're contributing significantly to the basically compute needs in big tech companies. Yes. So you have one foundational model that you can then make use of in a wide range of different use cases or applications within, for instance, the same company. But then if you look at like other companies in the world, not that many are at this point yet making use of them. And so I mean, I think like going back to the original like thought you had around zero-shot learning, even self-supervision and so forth. So it's I would say those are quite different compared to like the use of foundational models and the motivation for using foundational models. Foundational models are going to most likely become more and more popular, and I think it makes sense. Then, like examples like GPT-3, and not like most of the use cases I am seeing aren't necessarily in need of GPT-3. That you can do well with your Word2Vec or some other embedding,
or even much better, I would argue, in a large number of cases.
Yeah, but then I think then zero-shot learning and self-supervision and so forth, they have a little bit different use cases, and I think there you can see. Usually it comes from the actually like limited resources you have, rather than like going really for GPT-3 where you go for the biggest. You actually go for the like smallest. And you know, those certainly have use cases out there, but I still believe in many cases you're gonna end up in a situation where it's gonna have a much bigger impact to get more and better data than to sort of throw in more data scientists to build like better algorithms.
Agreed. I'm going to add a topic like later at the end, more societal, philosophical kind of topic about, you know, how to reach AGI and stuff like that. But I hope, is it correct to summarize that, you know, it's interesting to do research towards AGI, but if you want to really have use for AI today, this is not the right way to go right now. Would you agree with that? When it comes to foundational models, at least.
Yeah. I mean, like, maybe a little bit exaggerating on that topic, but I mean, I really don't see that we have technology today that takes us to AGI, and I don't think we are, you know, working on anything that will do so. So,
but I agree, but still, do you think that type of work with foundational models is leading towards, you know, having in some distant future something that is more similar to AGI?
I still see sort of I still see the use of them and the way that they create value as in a sense narrow. But I get your point in the sense that that's the best we can do. Right?
Today, yeah. Let's get back to that later. But I think it's a fun philosophical topic, you know, that we can just speculate about. Cool. Okay, so just getting back to Silo a bit, and of course we want to have, you're doing some research into the top challenges and continuously improving the components and infrastructure models that you do have, or modules that you do have. And that sounds great. But could you just, I think sometimes it's just so much easier to just understand what you're speaking about. If you have some very concrete example to speak about, do you have some like reference case, some kind of typical like user example that you can speak about that you worked with recently in Silo that tries to describe, you know, what you are providing as value for the customers? Could you give some example or one or two examples of that?
Yeah, so I can. I mean, we're working with three large specific segments: so smart vehicles, smart industry, and smart devices. And then, sort of the fourth, larger, wider segment is smart society, covering a wide range of the industries. The examples in smart vehicles covers automotive and ADAS, so working on
automotive and
ADAS, so basically driver assistance, autonomous vehicles, which implies that we're working with computer vision, with sensor fusion, on topics for self-driving cars, or for vessels. So we're working, for instance, with Rolls-Royce, with that is now part of Kongsberg, on autonomous vessels, and the same with the Mitsubishi funded initiative. We've been working for several years already on basically a system for autonomous vessels. The same within, say, mining industry, forestry machines, on autonomous vehicles for the mining environment or for forestry.
And I guess in that case, a lot of 5G technology involved as well?
It is involved as well, but to a large extent, you actually need to run there at the machine. So
there's edge computing in that sense?
There's edge computing, yes, and there's sensors. When I was saying ML infrastructure, data, compute and connectivity, then we have it all there. Yeah. So the compute needs to happen there, and it's safety critical in many cases. Right. So even though there is no connectivity, it needs to work, and then you have in many cases multiple different sensors collecting data. So you have cameras, but you have radar, and you have laser or lidars, and so forth. And then you do some kind of sensor fusion of them in order to sort of, for instance, help the driver, assist the driver in actually making decisions.
And sensor fusion, I guess there are a lot of topics to speak about just in that topic alone. But what's your preference there? And I'm a big, I follow Tesla and Elon Musk a lot, and how they, are working with their or full self-driving, as they call it. But I guess one way to think about it is how much should you do at the specific sensor itself, or should you just send the raw data to a central computing device that do the fusion rather in a more central way? Do you have any thoughts about that? Should the fusion happen as distributed as possible or more centralized?
Yeah, there's a number of different views on that specific topic, and I think the more important part is really what are the sensors you're making use of? What are you fusing? And there's been the view that whether you need laser or not, or lidar or not.
Yes. What's your thought about that?
I have a hard time. I have a hard time believing that you can reach full self-driving in a safe way without lidar.
Interesting.
And then also obviously we can see that the price point has been shifting. Yes. So when you were a student, the cost of lidar was many times.
I don't think the lidar existed when I was a student, but okay, thanks. Yes.
Yeah. No, I think there existed one, but it was really expensive. And now you can get a sensor for cheap, and it's you can integrate it in many, not only cars, but many other products as well. So, I think really lidar is going to play a key role there, and radar as well. It was a little bit like old school technology, but again, the price point and actually sort of accuracy that you can get from that is fairly significant. So and then the fact that you are getting more and more like AI and ML technology to actually fuse these kind of sensors and signals. So I think a lot of things happening there. Still, I'm as I've been sort of tried to be realistic and pragmatic with my viewpoints on AI and AGI and super intelligence and all of that. The same applies to like self-driving. It's we can assist, yes, but we have a long way to go to really full self-driving.
Yeah, given my fascination in this kind of full self-driving ability, I have to continue on this topic a bit more, I think. And okay, so let's start with the lidar versus cameras then. And if you were, the concept of straw manning and steel manning. Straw manning in straw manning, you basically try to find the worst motivations for some person and just speak about that. But in steel manning, you're trying to do the opposite. You're trying to find, if I were to put myself in the shoes of Elon Musk and say, why does he believe that lidar is not useful? Why would you, if you try to put yourself in his shoes, think that he does not believe in lidar? Is the price point the only thing, or is there something else, you think?
Well, at the time that they actually introduced the sensors and sort of initiated efforts, it certainly had an impact. And I think it hasn't been entirely predictable either how the price point is going to change.
Right.
Major role is also, I think, with the sort of with the fact that you'd want ideally a lot of things to be corrected with software updates. Whereas sort of you're with basically with camera and pixels from camera video images, then you're gonna be more flexible on that side. But I mean, I have a hard time sort of finding a logical answer to that. I mean, Elon was also believing in AGI and a number of other topics that I wouldn't entirely agree with. So,
if I were to try to put myself in his shoes, then, and please disagree now, but for one, of course, the price, but perhaps also, and I'm not an expert in these fields, but I guess one of the advantages with LiDAR is that the precision is much higher when it comes to positioning from LiDARs. So knowing the exact position in a 3D space from LiDAR is much higher than from a camera. And even if you have multiple cameras, it's still much higher when it comes to LiDAR. Would you agree so far that positioning is the big advantage with LiDAR?
Yeah.
And then perhaps, and I'm just guessing now, but perhaps, if you were to have, they have in a Tesla at least 8 cameras, and if you were to be able to do great sensor fusion with the cameras and use AI to a much greater extent, do you think the positioning could be overcome, so to speak? The lack of positioning capabilities from cameras can be overcome with smarter AI models?
I think it can get better, but it's gonna still have a lot of uncertainty, and I mean, then you can disagree whether or what a lot means and whether it's significant. But I mean, you've seen accidents that are clearly a result of the fact that you are not sort of measuring ground truth with a LiDAR type of sensor, where you might be hitting concrete blocks, or you might be hitting another car, or a plane, or something like that. That's not sort of immediately identifiable with the camera, whereas a LiDAR, on the other hand, would have identified it. So I mean, but I don't think it's really black and white. And then on the other hand, I'm also a little bit sort of less optimistic about full self-driving than many others, or Elon.
Okay, so give your best estimate now. When there are full self-driving cars already in some parts of the cities somewhere, but when do you think it will become mainstream? When do you think there was a famous bet, I think, like 1 month ago or something, between 2 famous people that I don't remember. They were trying to guess yes or no if in 2030 we will have full self-driving cars in the major cities throughout, I think, US in that case. Do you think in 2030 we will have full self-driving cars in the majority of our cities in US, for example?
If I need to give a yes or no answer, then it would be yes. But I think the more important question to me is how sort of restricted environment is that going to be? So if it's like predefined area where they're going to function, then we can do that already today. We just restrict the area so that we know we can do it there. And that's, a little bit what, in a sense, has happened so far. And my bet would be that for the best chance for us to actually increase the size of the area within which we can operate might actually be achieved with smaller investments if we would invest in infrastructure.
Awesome. Goran, I'm sorry to say this, but I have to have a small technical break. I'm trying to be containing myself for a long time, but I'll be away for 1 minute. But perhaps you can just speak a bit more. I'm really eager to hear, more what does really the name silo stands for? Because I was a bit confused when I first heard it, because silo, in my view, is actually kind of a negative thing. You want to get away from silos. And with that, I'm leaving you, but perhaps you can elaborate more, and I'll be back in 1 minute.
No worries, we will take over.
Sorry.
Yeah, so Goran, you will need to repeat it too.
So I guess the question was a little bit more about the Silo AI as a name. So where did it came from, and what does it stand for, and how does it correlate with the main mission that you had, AI for People?
Yeah. So yeah, exactly. And what my challenge was that you will need to repeat it for Anders when
he can listen to it in replay.
So no, but yeah, it actually comes from even before we founded Silo. We were building a product that allowed you to combine the human and the machine. So basically deploy machine learning models and then annotate them. So basically give feedback. And that product was called Silo Brain.
All right.
And Silo there referred to sort of a perfect environment that allows the interaction of a machine and a human. And really, I think in many cases, what we actually need, rather than having everything connected and like as huge of a data space and so forth as possible, we actually need a restricted environment for sort of machines and humans to interact. So that's really the sort of, if you try to find a technically correct story, that's the story we have.
That's the story. I mean, every startup has like a name, a story about the name. So it's cool to hear it.
No, indeed, and then at the same time, it doesn't really mean anything, right? So
it doesn't mean anything until it means something.
Yes,
right. Google didn't mean anything at the beginning. Now it means everything. So.
And the same is with, take a company like Slack.
Right.
Yeah.
It's not really representative, right?
No.
But it also has a story.
Right.
But yeah, so what I was saying, that Silo is the perfect home for sort of the human and the machine to interact. And that actually comes from sort of an original product we built even before Silo in another engagement where sort of you had a space where you could deploy and visualize and then interact with models. So basically give feedback on model output. Think 2015 or so, 2014 or so.
So Silo in that way is actually something where humans and machine can interact.
So it's an isolated environment where humans and machine can interact.
And I think in many cases we need that sort of smaller and more restricted environment for that to actually happen in a meaningful way. Then silos you can connect.
Okay. I think I understand what you mean, but.
And then I said to Goran that at the same time there is a story and that there isn't. So.
It's a great name, but it made me think when I heard it the first time, at least. What because in my view, silo is a negative concept. But I can see, if you phrase it like that, then it's still a good
thing. If it made you think, then it served its purpose.
Exactly. So it didn't mean it had a meaning until you start thinking of it. Now it has, so it's good. Right.
Okay, but it's not an acronym in any way. It's simply the place where humans and machine can interact in some way.
Right.
Yeah.
Cool. That makes
sense. You mentioned how long has Silo existed since the main since the start until now.
Yeah, so Silo was founded at the end of 2017.
Right.
And so we're now 4.5 years, around 4 years operatively active, and we've been growing fairly fast. So now 250 people. Last year we had 120 people join us.
Right.
So we've been a bit more than doubling on an annual basis, and
it's mesmerizing how successful it is. If you look at it, it's only been 5 years.
Yeah.
Right. You need to give yourself a kudos for that. That is like a big, rapid increase.
No, I mean we've taken small, humble steps, and we've grown with clients. So I think that is the really, like, we have no external investors or owners, but we've always had to focus on creating value and being really picky in what we involve us in and what we do not do, where we actually believe this technology can create value and where it doesn't, and then pushed for that. And I think clients have helped us grow to the correct direction as well.
So how is let's stay on that a bit. So how does the relationship between Silo AI and the customer actually is? So you said that you're picking up the projects that you want to work. How does it work? Is it like companies usually come to you, or you go to them and you find like use case, or how does it work?
Yeah, we are. Picky doesn't mean that everyone comes to us and then we only pick the best. I mean, picky means that we have a pretty clear vision ourselves where we can create value and where we would want to play, where we would want to help, and then obviously we need to convince also that clients believe that we can create value, but. There's nothing special there, but at the same time, there are not that many similar players.
No.
So when you come out with the background story of the company and who we are and what we've done, and as said, it's fairly humble and sort of client-driven story we have. In many cases, it's of interest. So that's really how we have sort of approached the market.
Right, and let's say that a customer comes in and he's interested in working with Silo AI. How does the whole process looks like? Do you have onboarding process, or it's how does it look like for them? Is it like a long-term project, or they just acquire the software? Or
so we basically we don't sell software, and we don't sell projects. We basically sell a partnership.
Right,
and that implies that. Obviously, we identify what they're working on, what they're trying to achieve, and so forth, and then we try to identify and assure that they have certain pain points there where we can help out, especially in building stuff. I mean, we're a technology company.
Right.
We're not strategists. We're not management consultancy. We jump in to build stuff.
right,
And then within the partnership, there's a number of different things that sort of involve. When you work with us, then you get access to our AI reviews. You get access to our, that I mentioned previously, and you get access to our learning activities. You get access to a number of different things that help our clients succeed on their AI journey,
right,
and sort of long-term sort of succeed with putting AI in production and running it there.
right.
But
And I have a question. Maybe we can place it a little bit later on. So you are our first guest that is coming from Finland. So I want to have like a little bit of a discussion regarding the Nordics and the maturity state in AI. And you have done as well research, right? In this, you did some reports on that. And so the question is a little bit more if we can discuss like the maturity of AI in the Nordics and the differences between Finnish and Swedish.
Shouldn't he rank like the Nordic countries in some way, perhaps?
Right.
In AI readiness or something?
Yeah, so actually there is like a little bit of research. Now there is a survey that is going out now. So Aero and the AI framework, they're doing a new AI maturity, but I believe that Silo did like a representation of the entire Nordic. You mapped that, right? Or?
Yeah.
Yeah. So, but we can leave that question for later on if you have a flow. Otherwise, I think it's a great, interesting discussion, because what I have experienced is that different country have like a different approach to what AI means to them. Not maybe what it means to them, but how they grab on the opportunity to implement this in their organization.
Yeah.
I would argue that for many organizations, since we started with Data Innovation Summit and etc., we have spent a lot of time in innovation and tried to experiment. But when it comes to scaling and putting this into production, it has been really difficult for many organizations. And part of that is actually about culture of making decisions. In Finland, that decision making is a little bit different than it is in Sweden, because here you have the fika decision making time, which is basically, sorry, was that maybe?
No, it's
right?
okay.
So the fika decision making time means that we need to reach a consensus about if we're going to go forward, rather than in other countries you will find like a person taking a decision. It was like, I think this is the best approach forward, right? So that was the
Yeah. Let me comment
long question.
Let me comment that first, and then if you allow, then we can jump into the topic. But
you decide.
This fika decision-making culture is certainly, it has many sort of advantages and disadvantages. I don't know, but the thing is that when you then eventually reach consensus, then you actually commit,
right.
At least better than sort of maybe faster decision making and less commitment. And I think this is the major issue we are seeing really is there's a lot of initiatives in the Nordics and in Finland. I think what we saw that most individual initiatives were, according to the survey we did were in Finland compared to other Nordic countries. But if you look at the aggregate R&D investments, Finland was like multiple times behind other also per capita. So
behind in what specifically?
Investment
aggregate R&D investment.
Okay.
And I think that again, like my point there is really that again points to the fact that there's a lot of small projects, experiments, proof of concepts, and so forth, but not that much commitment to actually push all the way to production, and I think that's really the crucial. Not the crucial part is not the number of initiatives.
Do we have a blueprint of how to scale things into production? It's also a question because we see it on our conferences, right? It's the number one topic.
I think there are clear recipes for how to fail to put it in production, at least.
Well, I mean that is great, right? Because if many people fail and you mark the failures, that means that we are closer to a solution. Isn't that the whole point?
Yes, I think it at least is a small part of the way forward. What do you think? Is there a nice recipe for how to put things in production or how not to put things in production?
No, I mean, this has nothing to do with regulation, but it's my view on this is a little bit the same as with regulation. You know, you can't, there's no sort of one size fits all, and it's really going to be dependent on what you are actually trying to achieve in what type of context. If you talk about product company, company that has a digital product at the core of their business, the blueprint is very different compared to like looking at a traditional business, a retail company or some industrial manufacturing company. And they are going to sort of do it at scale. They need to first build out their digital capabilities on top of which they can do it at scale.
Right.
So you know, I think we might want to move there to that discussion. But as I've said several times, I mean, I believe AI needs to be approached as a product or as part of a product. Right. So, and this I think is one of the major issues with sort of trying to scale AI without actually having sort of that digital platform on top of which to scale, and that platform needs to connect to the sort of technological components and infrastructure and data and so forth, but also to the business cases.
Right.
When you have, in many cases, sort of you are trying to approach scale by identifying business cases and then trying to sort of build those separate point solutions to scale. And I think that's going to sort of, you are going to reach dead end in most cases there.
Right.
So investing sort of in actually building out sort of scalable infrastructure,
modern
digital
data platform. Yes, right.
Yeah.
Hijacking that.
The problem with the discussion I think we're having here is that we agree too much on things, and that's probably a good thing in some way.
I don't have any problem with disagreeing completely.
No, but the thing is, if we are thinking the same thing, it doesn't really make for good discussion. So I'm really going to go on an edge here and actually disagree on something. And it's tough for me because I agree, of course, as well that, you know, the way to make something, you know, work in the end and put it in production is to have a proper digital product or platform that you can build on. Otherwise, it's super hard to build something with AI separately, if that's correctly phrased. But then, let me try to find another way to phrase it. And I would say that, yes, the easy way to put AI in production is to make it a part of an existing product or of a digital platform, and that will make it much more safe to make it work. But I think potentially you could be missing out on some things. And what I'm trying to say here is that we have some product. It could be a manufacturing product. It could be some kind of recommender system, or it can be some kind, you want to have an e-commerce site or whatever. And then you have a product and you want to optimize it somehow, and that's great. And you have domain experts that know that this is the metrics we're trying to measure it with, and let's try to use AI to improve it in some way. And that's usually rather safe, and you can easily see if it works or not. The problem is then, how do you find the big transformative changes, the big changes in how the business works or how the product should work, if you are always requiring it to be a part of the existing business? So if I give a concrete example here, like I guess like Spotify, and normally people are manually building playlists, and you can help people build playlists by giving recommendations for them to improve the playlist. So that would be a typical example of like bottom-up scaling, I would say, that you take a product and you improve it with AI. But then if you take a thing like Discover Weekly, which is completely personalized playlist that is having a separate playlist being built every week for every single user, that's a completely different product that didn't even exist before and wouldn't be possible to build without AI. If no one would be able to come up with that idea, which is a completely new product, it's not an existing digital platform, it's not an existing product, it's a new product that is built, that was impossible without AI. If you don't have that as well, then potentially you would miss out on some, really big scaling products. Would you agree?
So with this last example, who would be the one developing this new AI product, the music recommendation product? Would that be Spotify or would that be someone else?
Spotify in this case, yes. Yeah.
But exactly, I think the issue is that we might end up agreeing. So no, but if you look at that case, then it is already a product company. They already have a long-term commitment, and it's fine to innovate. It's fine to do like your new product and then integrate it, but it's more really, I think it's partly it's a mindset, a way of working. There's like when I'm saying product versus solution, for instance, and then with the solution, your mindset would be that, okay, come in, start today, end after 2 months, deliver, and then it's done, and then it's in production, and we're ready. And you might not have any idea about what kind of like deployment infrastructure you need and how you operate it in production, how you further develop it, and so forth.
I see what you mean.
And I think many, I won't say most, but many traditional, say, from companies from traditional industries that are not like technology, especially not digital companies, right. They approach AI from the perspective that, okay, I have this problem. What could AI do? And then they think about like, how could AI help with this specific, then take this music example. But if it would be this record store here around the corner, even though they would build this algorithm that does it, they have nowhere to put it and they have nowhere to operate it at scale.
I see. Yeah, then of course we agree. We need to have the proper infrastructure in place to have an AI product working properly. But
just to basically add, because that sounds really trivial, right? Mm-hmm. Okay, everyone understands that, but unfortunately that's still the case. I would say that majority of I would say even majority that this type of like solution ideas that we get, I'm exposed to, they don't have a business case. As long as you're not committed to long-term development and then assure that the business case actually works. So I think it's really about the mindset with which you are developing that. But I mean, there's a number of things that impact your success in doing so. So it's not really that trivial, I would say.
Cool. Yeah, agreed, unfortunately. But going back a bit to how you at Silo are choosing customers or projects to work with. You said perhaps not being picky in that sense, but still, you said what to do and what not to do. So would it be correct to say that one major reason for Silo not to do something is that you're not seeing that they do have the digital platform in place to truly put something in production? Or would it be the opposite, that you're seeing a company that have a great product, but they don't have the digital platform, but you do, but you have some kind of infrastructure modules that could truly help them? What's your thinking there? What is really making you choose this is something that we think could be something that we at Silo could help with?
Yeah, I think I think it's when we say like platform and scale, it's partly the technology there. So it's partly that you have that data platform and you have that infrastructure that allows you to run in production. But then the other part of scale is that you actually have basically the business case for it, and that it's at the core of your operation. Like if you actually succeed with it, is the impact as big as it should be, so that it makes sense for you to say, put together a team of 10, 15 people and have it work on the product for, until the very end, right? There is no end. And I think that's really the major part of it. And then it implies that you are treating it as a product and product development initiative. And I think, this is if the viewpoint is that, we have this idea that, a lot of people are reading too many documents or getting too many emails and we'd like to have a solution for that. Can you deliver that? It's in most cases the sort of answer to that. If we want to be like truthful and actually assure that we are creating value when we work together, then we would say that no, we cannot really. And then on the other hand, if we stay, as we most often do, we stay at the core of the business. Really, when you do something better, you have scale there. And
I think if Henrik would have been here, he would have said, you need to have the economics of scale. Yeah. Is a term that he loves to use, and I'm not sure I understand properly what he means with that, but I guess in some way it means that if the business model doesn't scale with the product in some way, and it's not really formed in a way so the economy can really scale with the product as it scales, then there is something wrong. But if you can find that, then it's a good use case for Silo potentially. Would that be?
I think it's a good use case for AI, right? So it's really like there's going to go in a fixed cost to develop it, and then if the sort of marginal cost is going to decrease with the use, exactly. And if it goes low enough, then it makes sense to do it. And the same thing is if you can do a better car with the help of computer vision and sensor fusion, it makes sense to invest in that. And if the same applies to your mobile phone camera or music recommendation algorithm or video or book recommendation algorithm or Google search and so forth, there you really have like algorithms at the core of the product. And now it's easy to find these examples when you look at these tech companies tech companies, or say automotive or companies producing smart devices and so forth. When you look at industrial companies or when you look at other like traditional industries, it's not that straightforward anymore. And then, you have the questions that you also had. That what does it actually mean then? What is a product then? And to me, really, then that's when it becomes interesting, and that's where you can do this transformation. But it doesn't happen through AI. It actually happens from the company understanding that if I'm gonna be like manufacturing company, and the interest here would be production processes, for instance. If you're going to approach that, then you should not be like reaching out to a partner and say that, can you deliver this project? Can you do this solution? you need to commit to assure that you build out basically that competitive advantage,
Right.
and then you can basically scale that, allow it basically to continuously run and continuously further develop it from every interaction, and that's where I believe that you actually get the value. When you do that on a like project basis, you're gonna get something. And if it's good, it works for a while. If it's not going to end up staying in production or ever going to achieve that level.
Awesome. And the time is a bit flying away here, but I have so many talks I want to cover. But just to linger a small part on that, because I think you said a number of good things, which is you need to commit not only to deploy, but actually to keep that in production for the long term. What about concepts like failing fast? And just to give a reference to that, I remember Daniel Ek in Spotify once said, we are going to be the company that fails the fastest. And that may sound weird, but still, what he means, at least according to my view, is that there are so many things that are exploratory, and especially when it comes to data and AI. And if you were to differentiate between traditional software engineering and building products and more to AI engineering, which is products that have some kind of AI component in it, the exploratory nature is so much higher. So it's so much harder to know in advance what actually will work or not until you actually try it.
Yeah.
And therefore, you need to fail fast, potentially, for things that doesn't work out. Do you see what I mean?
Yeah, and I actually haven't thought it from that viewpoint, but I mean, I think that's very interesting, and to me it actually supports. I mean that concretizes the issue here. So if you fail fast with AI projects that are not built sort of on top of a product, you're gonna fail with everything. Because you're never going to be able to show the business case there. You're never going to really be able to show that this actually works. Because you're going to fail before you are like there. And that's why I think it's you should be failing with certain like AI projects that are built on top of that digital product, that digital platform. But you can basically you will only know if they have a place where you can actually see how well they work. And what we are seeing now with all of these like experiments and trials and proof of concepts and pilots and whatever you want to call them, that we know that tons of companies have been doing around AI in order to find that holy grail, and majority of them have failed. Clear majority of them have failed. I think that's what happens basically. So you should. But
do you think it's right or wrong that they have failed?
Yeah, I think you should continue failing fast. Yeah. But you should give it a realistic chance to actually succeed.
Okay, so some are even failing too fast potentially. Is that what you're saying?
Yeah, I mean, if you don't commit to the sort of underlying product development that is required for you to, if you are a retail or media company or like manufacturing company, and you do your proof of concept. Of course it's gonna fail because you don't have anything where to plug it in, right? So
cool. I like that. That's a new view from my sake as well. And I guess you need to have the proper, what should you call it, preconditions to have a product working. And if you don't, you shouldn't fail because the initial results look weird if you don't have the proper, platform to build on. And if the platform is the reason for failing, you should stick in it, or you should stick with the product. But if the reason is that the data is not supporting the use case, then it may be okay, right? Is that the correct way to reason?
Yeah, so I take as an example, I saw that you've had Errol Kuhlmeister as a guest. So I think H&M is a good example there. Yeah. So there you take a traditional company coming from the retail industry, not a technology company. Yeah. And I've worked with him for and seen the journey for many years. and I'm not gonna say I know how they did it and what they did and all of that, but I mean, they put a lot of efforts in assuring that the foundation is there.
Right.
And now the way that I would, like in my eyes, it is a technology company. And they have put sort of technology or the digital platform at the core of it. And now there's tons of like AI products being built on top of that. And they get a realistic chance to actually succeed.
So by putting the foundations there, they can iterate quickly and then find the proper products on top of it. Yeah. That I think makes a lot of sense. Unfortunately, we agree again. That's true. But I think it also puts like a double view on what failing fast really is, and perhaps we shouldn't fail too fast. We should only fail fast for the right reasons, right?
Yes, exactly.
Awesome. Time is now gone 2 hours. So let's try to move a bit more into some more.
No. I mean, if Peter is game, I think that things are getting right now on the where we're supposed to be. So he decides when we end this.
Yeah, but if it's okay, keep it for 20 minutes more or something.
Yes. I have a late flight, so it's okay.
Right, and we can do after work as well.
Yes,
so
yes. We have to have time for the after.
And it's an honor to be the first Finn here.
Oh yeah.
Yes.
I have to admit I'm a Swedish-speaking Finn, so you're cheating a bit. But
Yeah, but it doesn't matter. You're from Finland, so I think it's good. So it's the first. I have a question. So all of these cases that we are saying that is good, but in the same time, what are people doing wrong? Because the reality is that not many organizations. There is more actually project being killed than project being put in production, right? So in any of these organizations. And to some extent, what I experience is that we are buying a car, but we don't have a license, or we don't have an idea where we are going with it, right? So we are buying it because somebody else is buying it, and because we are buying the hype. And was like a lot of discussion, even on the podcast and out of that most of these cases where we are applying AI, probably we don't even need it. Right, so I think there should be a healthy discussion about like, okay, where do you actually implement this? When do you need it? And as you say, like if you are using it, then you need to commit to deploy it from stakeholders, from management, from everybody else. And then Anna, she's a change management agent. She wrote like a lot of books. She said AI is a change management topic because not many people are, let's implement it, but what happens after, right?
Yeah.
Let's talk about AI life cycle. How this is going to look like in 10 years when you have tens of thousands of AI models in production. How will your data management strategy look like then? How is your life cycle management of the AI look like then? How do you actually merge everything together? So making this story long, because I think that there is so much more we are not talking about, right? Because scaling one project in production is great, but how it will look like in 5-6 years from now?
Yeah.
And we need to start preparing for that right now. We cannot prepare now in 5 years, we do another conference and then we talk like, hey, well, it's time now to do from spaghetti to make a mash or whatever they talk about right now, right?
Yeah, no, so I think we are most often, we are sort of, if we talk about like change management and the organization, then, I mean, our core is, we're a technology company, our core is to build stuff, and whatever we then build, we actually believe in, and then we try to assure that we get success on that side. And then at the same time, we are in many cases also sort of running internal accelerators and so forth, so training and trying to sort of get the company to see the opportunities out there. I think that's an important topic, and you can approach it in many ways. I mean, you need to, again, like there's every company is different and requires a little bit of a different sort of. If you take a technology company or a very traditional company that has no technology in product or no digital products in production yet, but then you said that companies are are failing with most of their projects or many of their projects in the current market. And I think that's, I mean, I would still go back to the same things that we partly back to the same things that we just said, but pinpointing really the fact that in many cases we see companies out there looking for sort of tools to problems where there is not really that much value to be gained. And you need to remember that it's like AI is nothing that you basically just apply, that you take off the shelf and put there. The way that like you build an AI solution yourself or product driven by AI, then it's actually a pretty significant investment in many cases.
Right.
And if the problems you have there aren't actually that significant, then you're gonna fail. You know it already because basically you know that the sort of upside or the gain with that problem is not large enough. And that's why like this scalable part or economies of scale as part of a product, because products usually would be targeting a really wide audience. And if you sort of even improve it this much, or if you create a competitive advantage compared to the other automotive player or the other smart device manufacturer, the impact is significant. And I think that's why it's so important for you to be close to the core of your business, and assure that the sort of business, the value there, the gain there is large enough.
Right.
And then you need to commit to the investment that is required for you to get there. But I think the issue in many cases is that in this hyped market, many are still. I mean, we've been seeing this for 5 years now, or more. But 5 years, say, has been the time span within which people have been like constantly pushing for AI proof of concept here and there, and a lot of the cases that are approached with this, there is really not a business case in place. You shouldn't be building it. You should be buying a product that has AI, maybe.
Right. I think it's me and Henrik had like a discussion before. So usually before we create these events and editorials and etc. How I feel is that basically this came so sudden. The machine learning and AI after the 2017, it was the World Economic Forum when PwC launched the report of $15.7 trillion to the world GDP contributed by AI by 2030, and then suddenly machine learning was the A game, right? Everybody wants to play the game. So there was a large investments actually in majority of the organizations to create data science teams, create like innovation engine units, whatever you want to call them, acceleration units, and dedicate a lot of resources, both financially and workforce as well, for them to innovate and for them to create this innovation engine, basically, right? But now after 5 years, and especially when Corona hit, you could have seen that there's a change of mentality, because it was not longer, this is not longer just a game, we need to provide value with this, and especially because the market changed very rapidly and circumstances changed very rapidly. The whole stock market went 70% down, so it was very volatile type of a situation, and you could have seen that there is let's say like a word coming out from the management, so like, okay, where is my investment now? How do we actually get value realization of this? And I believe this is actually what is the difference between the 2 years ago and 3 years ago back and right now, because I believe that people are looking for value realization of data and AI as soon as possible, because otherwise you will have to go back and take away some of those resources, because you need to focus on what is right. Business doesn't wait for anything, it's just move on. If you had like 6 or 8 months to do a POC on a project that actually right now is not even relevant, because it was relevant in the time when it was created or put to be solved, that I don't know. We need to be faster to value realization, and I believe that is the main topic here. How do we get faster there?
Yeah. Yeah, I think how do we get faster is important, but I would rather suggest that we should sort of stop for a while,
Right.
look around, and then sort of think about what direction should I take when I run faster, and now, because what we have been like running in circles around is the topic like what is a product, what is not a product, and where should you sort of build AI, where you shouldn't you? It's really a sort of buy or build question.
Right.
The way I look at the future, AI is gonna be a part of close to every single digital product out there.
Right.
But you do not necessarily develop them. I mean, the same with the, if you look at the IT boom and the time after that, there was sort of a significant interest in building your own, be it then your website or app and so forth. But again, in the same way, like not everyone should be doing it. Like either you build it, or you buy it.
Right.
And then the question really is the use case, is the value much bigger actually for the product company that is solving that specific topic? Then you shouldn't be developing. And in a lot of these solution cases out there where I don't really see value, for instance, a lot of them are topics that should be tackled by product companies. And really that's why I think you should identify where is your core and where do you want to create competitive advantage. And then you should sort of put your AI efforts there. And that's why sort of, when you said that, a lot of companies have been building data science teams and now they are asking for return on investment there. Yeah, I mean, I think a lot of issues is then, where do you actually get return? And there are many companies that do not necessarily need their own data science team. Right. Unless they actually start to sort of become a product company in the sense.
Right.
Agreed. But also just to disagree a small part, I'm trying to find any angle I can to disagree. One, and I certainly agree with the build or buy question, but perhaps one difference is that if you take a traditional kind of other functionality that you can build yourself or buy, like you want to have payment solution, for example, that piece of functionality, if you're not really super strong in doing that, I mean, in most cases it's better to buy that piece of functionality. Potentially for AI it's a bit different because it is possible to train and adapt to your own data in a way. So if you buy something and it doesn't have the ability to adapt and train on your own data, then that could be a bit more difficult. So in that case, it is not. There can be cases, at least when it comes to AI, where it is necessary sometimes to build something that otherwise would be possible to buy. Would you agree?
Yeah. Yeah. But certainly, I mean, if you're actually willing to commit enough to that and invest enough, and you can see that there's a sort of significant gain in doing so, but I mean, I think you should think twice, or 3 times, and
I would like to just rephrase what you said, because I think that makes a lot of sense. AI, for one, is a large investment. And there needs to be a big business potential if you are going to do that investment. Something with economies of scale that you can actually reduce the margins if you do, or if you are able to scale. Otherwise, it simply will not work, and you will not find profits from doing so, right?
Yeah, exactly. And if you look at the if you look at the successful cases out there, obviously there is a wide range of them, but the big successes like Google, Amazon, Spotify, Netflix, and so forth, they all have it at the core of their product.
Right.
And it sort of, I think one I've been referring a few times to Mark Andreessen had a good article in Wall Street Journal 10 years or so back, and he referred to software eating the traditional industries, right? And that was about network effects and so forth. You know, you could write the same article now, but with the focus on network effects and platforms and all of that combined with AI, which further strengthens the impact of that. So sort of your products are getting better and better and better from every single user that joins, but also every single time someone uses that product. Exactly. And I think that's where you really want to be.
If you find that effect, then it's probably a good use case to have, right? Given your also economic background, it would be fun to hear, a quote that I usually or very often use myself, which is from AIAW, and he's a professor in economy, but he also, I think he calls himself a professor in AI these days as well. But anyway, he basically compared AI to other big economic disruptions that happened throughout the years, and he compares AI to the internet and the transistor, and the transistor led to the computers we all have and use today from the 1950s and forward, and the internet from, I guess, when the web became popular in the middle of 1990s. And he said, something that it's easy for an economist to define, what the disruption is. It's basically when the cost of something drastically drops, then you will have a disruption. So he said, transistor and the computers made it, significantly cheaper to simply do calculation, and that, changed the jobs we had and created new jobs we've never seen before. The same with the internet. And now it says with AI, the same will happen. Now, once it actually becomes powerful enough and popular enough, that the cost of making predictions, in this case, as he claims it, is going to drastically drop in cost. And that is going to cause our jobs that we have today to change and create new type of jobs. And he even claims that AI will be a bigger disruption than the internet and the transistor was. Do you agree with this?
I don't think this is a yes or no question.
Please elaborate.
Yeah. The way that I've always looked at AI has been that it's one among many other new technologies that are going to change the way we work, that are going to have an impact on society as a whole. But I don't see sort of an immediate major disruption there. And I don't myself see a disruption that wouldn't be tackled by functional job markets, labor markets.
Is it dysfunctional, or what do you mean? Or
that wouldn't be tackled by functional labor markets, which implies that I strongly believe that the labor market is going to adapt, and there's tasks that, yes, with technological advances in, AI, but I mean with AI we mean usually sensors and compute and connectivity and a lot of other things that are going to, for instance, allow manufacturing companies to concentrate the sort of work of a human operator that is doing quality control to an individual that is basically monitoring, instead of one production line, then 20 production lines, and as one example of many. But yes, I mean those kind of changes we're gonna see out there. But at the same time, there's going to be new tasks. People are going to be able to focus on different things. You have a lot of mundane work, as you yourself said earlier, that machines are going to take care of. That's going to allow humans to focus on other more creative tasks, more value-creating tasks.
But I think I also said, new jobs is going to be created. So it's not really necessarily going to be a reduction in the labor market, because of this. It's just that it's going to be a shift in some way.
Yeah.
Right.
Yeah. Indeed, and that's how I maybe also interpreted it. But I mean that's there's going to be change, yes. But I mean I think well-functioning labor markets are going to tackle that, and the sort of the net effect is going to be positive, right? So but then when you think about what is the impact of this technology wave compared to other technology waves, and yes, it's going to be big, but I've been now pinpointing like the fact that AI is sort of built into products. I look into the future. I see that it's part of it's already part of your.
It's a natural component of every product we have, basically.
Yes. So it's gonna improve them. It's gonna automate certain things in the background. When you do a Google search, it's a little bit better. When you listen to music, you get better music recommendations and so forth. I mean, if you look at I don't think you can compare these two like side by side. But if you look at the internet, for instance, it has created a total new set of products, right? So I think it's difficult to compare side by side. You're going to have like a lot of impact in a really, really wide range of products. It's going to sit everywhere. It's someone compared it to electricity, right? So, but at the same time, it's not going to be, I think, as transformative in, we had no mobile apps just some years back, right? And so forth. So I do think that like the transformative part there is going to be different.
Interesting. So okay, let me phrase it like this. I have to give another Elon Musk quote then. But he also, when given this question, he tries to phrase, what will the impact of AI be on our society in like 10 plus years or something. One thing, and I'm paraphrasing here a bit, but one thing he said was that the future is going to be a future of abundance, meaning that we will have more and more of things. We will have the more things being automated around us, and we can easily have whatever food we want, whatever kind of transportation we need, whatever kind of energy we need, and whatever kind of education we need. Simply going to be more abundance of whatever we need, and perhaps we need less. One exception could be labor potentially. We have seen a decrease in the hours of work that we have per week in the last 50 years, going from 60 to 40, and perhaps it's going to go to 20, who knows, in coming 20 years. Do you think that's a good, or is that in line with what you think as well, that the future in coming 20 years will be like a future of abundance in some way?
I believe that, and that we can see already. I mean, with the development of as a result of the latest technology waves, and if you look back into the 90s, you say 20 years now forward. If you look 20 years backward. The sort of what technology has enabled us to communicate, for instance, and the way the efficiency efficiency gains they're huge, especially if you look at your sort of not how you work, well, obviously that as well, but
Corona times it was a big transition, right?
But especially free time. I mean, the way you can interact with people and sort of how you can spend your free time rather than doing a lot of, say, mundane work, or rather than coordinating everything beforehand because you only have a landline to call someone with and so forth. But has that changed the amount we work? We're compare our efficiency.
But 50 years back, at least, I mean, it changed a bit how much we work, right?
But certainly some, but I wouldn't say that they're technology driven, those changes. I mean, and if you really look into the future, do you believe that we would work like if you look 20 years back? I think the length of the workday hasn't really changed, right? If you look 20 years forward, I'm not sure. I do think that we already have our robotic lawn mowers and vacuum cleaners and so forth. Self-driving is going to be in a sort of more or say in a larger role than before, whatever that's going to be then. But there's going to be a lot of more free time. I do still believe we as humans sort of have our need to work or have a passion to work on topics that are relevant to us, and I don't think that's going to change. Maybe
I don't think for you especially personally. I mean, I'm sure you put in much more than 40 hours a week in work, and so do I actually. But so you probably got to do that, even though you may not need to. I guess you don't even need to today. But still, the motivation for doing work may change in the future. Is that a good way to phrase it?
Yeah, that might be a good way to phrase it. And that was actually sort of the sentence that was going to follow, in a sense, was that you're going to be probably more driven by passion.
Yes, well put. Awesome. And if we're trying to end off here with some final philosophical questions, and I think also what Silo is trying to do here with our mission in being like a big European player when it comes to an AI company, we can easily see that there are some really big AI companies in the world today. And I mean, Google went in 2015 saying, we're going to be an AI first company, and we have the big tech giants in the world, Google, Facebook, Amazon, Microsoft, and so forth. And Chinese companies as well, of course, with Baidu, Tencent, by Alibaba, and so forth. And they are really, accelerating in value in extreme. And there was this kind of report coming from Stanford like a month ago, and they annually try to measure a large number of things when it comes to AI. And one thing they measured was the amount of private investments in AI. And then they can compare the US as a continent to Europe and Asia. And they could easily see that there is a very clear trend. It's an exponential trend, but there is like a magnitude in difference when it comes to US literally having like magnitude higher amounts of investments, and that's accelerating even faster. And Chinese is on the second level, and Europe is like third on a rather strongly lower level, but still are accelerating, of course. Everyone is accelerating in their investments in AI, but on a very, very different level. Are you concerned with this? Are you concerned that the gap, the divide between these type of either tech giants, the few people, the few companies that are accelerating so quickly, and that we have so few in Europe? Hopefully Silo can try to bridge that, but still it's some way to go. Are you concerned that some companies are growing this quickly in the economy of scale and their way of using data and AI to just automate and scale everything and becoming so valuable as they are?
Yeah, I mean, I think what you said is a good summary of the current situation. The way that we look at it is that, or if you look at Europe, we have a lot of SMEs. And we
successful ones as well, right?
Yeah. but in comparison to the large players in their industry, usually that's not enough. And then basically we have quite a lot of players in the traditional industries. So companies that will need to sort of do their digital transformation and AI transformation still to stay competitive. And I think those companies need help, right? So the way that Silo looks at it, I mean, we're not gonna be able to sort of move the needle in terms of how many big tech companies we have in Europe, right? But what we can do is help the sort of mid-sized companies that are fairly traditional to actually sort of make use of some of these latest technologies and transform to even be AI driven. And to a large extent, I think in the current market, it is also a sort of talent war. So the question, like, I mean, if you look at it from the viewpoint of, for instance, Finland and Sweden, the Nordics, we have really, compared to the population, we have an amazing educational system in universities and talent. If you look at it from the viewpoint of academic talent, the people we attract to the Nordics are usually here for the short term. They do a PhD or a postdoc. And I think we haven't been that successful in actually keeping that academic talent in the region. Yes. And this is an important, that's why we started out with saying that one of the key, intents that we have is to assure that we keep leading AI talent in Europe. I think that's one of the major starting points. Now, obviously, I am sort of concerned about the sort of situation in Europe. But we need to pick our battles and do what we can and where we believe we can have an impact, and that's where I think we can contribute.
Agreed, and I think you're on a very good path of doing so and helping other companies to truly understand the value. If you do, for one, build a digital platform that they need to have as a base, but then also how to scale up properly using data and AI with the right tooling to do so and competence. I think Silo AI is one of the best ones to help with that journey, right? Or can you disagree?
No, I think we need to agree once again.
Awesome. Okay, so final question here, and more philosophical again. There are a lot of people that are speaking about the potential bad uses of AI and singularity in some, or a lot of people speaking about, and I guess you can define singularity as something different than AGI, potentially saying that you have human level intelligence. We are very far from that, of course. AGI could be something even much more intelligent, super intelligent than humans. But singularity, if we choose to define it as the point when we lose control of something, thinking like Terminator or the Matrix or whatnot, but thinking at some point there may be that the machines in some way are taking control and we can't really pull a plug anymore and we can't really stop that. Is that something that you are scared about? Or do you think we will, in foreseeable future, still be able to keep in control or at least have the machines to work together with humans in a benevolent way?
I think that's an important philosophical topic.
We are the last question here. We're supposed to be very philosophical. And
I'm still sort of, from a philosophical viewpoint, I think there's a lot to learn from having that discussion, right? And I think it sort of sparks a lot of thoughts and discussion and questions that might be relevant even though we are not really there or we're not gonna even really be there. Yeah. I don't personally see that we have technology that would take us there.
Not even in 20, 50 years?
I don't know what we're gonna work on then, but the technology like we are working on today in be it in industry or research or academia, but I don't see that we're working on technology that is going to take us there, right? So, but that said, I think it's important that we have those discussions, because that's the sort of grand scale. Yeah. You're gonna have that much smaller scale in many industries, in many specific use cases and application areas and so forth, where it might be a relevant discussion. But and I've been always a little bit skeptical about all of these discussions and pushed down that, but at the same time I am concerned about sort of ethics and other risks related to models and machine learning that is deployed, and being concerned with sort of model bias, or being concerned with fooling models, and a number of other like technical challenges and risks and issues when you actually have machine learning in use, and those are the things that I think that the technology companies should be working on and tackling and solving. And again, that's something where we can help, and where we can do something to actually help and improve the technology being used in a fair and correct way.
Well put. Very much agree once again. But let me rephrase it then. I actually think the bigger concern than AGI is actually the abuses of narrow intelligence. And if we were to use the technology we do have today in AI, when it comes to using it for autonomous weaponry or drones, or perhaps someone can release some kind of AI system that can abuse stock market or something else to an extreme that leads to another economical crisis, that would be much more concerning, and especially since the narrow type of AI does not have any way to think about the consequences. It's just taking short-term decisions to maximize some gain. And to me, I'm much more concerned, at least for the narrow abuses of AI, rather than at the time when we have something that's more intelligent than us, that can probably think about the consequences in a much deeper way than even we can. So I'm personally much more concerned with the short-term, narrow abuses of AI.
Yeah.
Would you agree?
Yeah, I would agree, and that's a significant risk. I think the main question there is really how do you actually approach or then regulate that? And my issue with that discussion also has been that's been a little bit like viewed from the perspective of AGI in a sense. You have something generic, you have an AI. Yeah. How should we regulate that AI? And to me, it's really an application-specific topic. In pretty much every application, you have a little bit different risks, and you have a little bit different sort of approach you should also take in regulating that, and that's why sort of yes, we should be concerned, but I mean, if you and this is maybe sort of again exaggerating a little bit, but you can't do whatever you want or with a hammer, or you can't do whatever you want with whatever tool that is given to you. So in a sense, like AI is, when I say AI for people, I said that it's AI by, with, for people. So we are basically creating the data, we're creating the algorithms, we're using the algorithms. Eventually, we have humans always at the very center. Yeah. Humans are eventually always responsible as well, yes. and I think this is no different. So eventually, sort of, we are making this somehow much bigger than it actually is, because with every tool that is not sort of somehow autonomously doing something on its own, eventually someone is responsible.
Yeah, and I'm eager to go into the AI Act and regulation, but let's not go there. We don't have time for it, but it would be perhaps a discussion for the after work. Cool. With that, I'll thank you very much, Peter, for joining us here at the AI After Work. The number of discussions and topics we still have left is large, but I think we got covered a number of very important topics, and it was a true pleasure to have you here. Thank you very much.
Thanks a lot. Great pleasure joining you.